Let's find the shear and moment everywhere along a cantilever. X equals 0 is the free end, x equals L is the part attached to the wall. It has mass m, a weight capital W, and a weight per length small w. If you solve the physics 1 problem, you find that the upward force at the connection has to equal the weight, and there also has to be a clockwise torque, or moment in engineering, equal to minus the weight times the length over 2. Now, to find the shear and stress at any point along the beam, we imagine cutting the beam and looking at the segment that was cut off. So this is the same as the entire beam, just in miniature. There's an upward shear at the right edge of it and a clockwise moment applied to it to keep it from tipping over. The weight of it is actually little w times x. Now there's a sign convention in engineering that I drew on the right when I cut a beam up into pieces A and B. The shear counts as positive if it's downward on the left and upward on the right, and moment is positive if it's counterclockwise on the left and clockwise on the right. So you can see that we're going to have a negative shear and a negative moment. So the shear turns out to be negative small w times x, and the moment turns out to be minus small w times x over 2. So the moment is a downward parabola starting at 0. Shear is a downward slope straight line starting at 0. And the weight per length is a positive constant. These are examples of the relationships that the derivative of the moment with respect to x is the shear, and the derivative of the shear with respect to x is negative the weight per length.